Track gauge varies around the world, from the 914mm narrow gauge found in South America to the broad 1520mm gauge used in Russia. But one thing is still important: maintaining that gauge. So what is track gauge? Track gauge is the distance between the rails. Specifically, it is the horizontal distance between the running edges of the rails. The standard rail gauge in the UK is 1435mm in plain line, where the rails are inclined, and 1423mm where the rails are vertical, such as in certain types of S&C. This is also common throughout Western Europe and the US. Measurements for gauge, whether taken by hand using track gauges or by train-borne measuring equipment, are taken at 14mm below the crown of the railhead. So why is correct track gauge important? First and foremost, correct gauge is important to ensure trains stay on the tracks. Both tight, when the rails are too close together, and wide gauge can cause trains to derail. For wide gauge, the wheel will simply fall off the rails. When the gauge is too tight, it can cause a number of issues. These include wheel flange clipping, where the flange starts to rub against the rail or catches it, which can cause the train to lift and then derail. On curves, trains tend to move slightly off centre, so that the wheel's semi-conical shape can allow the outer wheel to travel the longer distance. Tight gauge stops this from occurring, causing instability and possibly overturning the train. Increased lateral forces, caused by the restriction on the train's natural movement by tight gauge, also leads to increased wear on components, such as the rails. This can weaken them over time, leading to failures. Aside from the immediate concerns of keeping the trains on the rails, correct track gauge also contributes to the stability of the train. Track geometry is designed with correct gauge in mind, so for optimal rail-wheel interface, the gauge needs to be correct. This gives trains, particularly at high speed, travelling around the curves, the optimum interaction between the rail and the wheel, giving the highest level of stability if the track design is correct. This also leads on to ride quality. Similarly to track geometry, trains themselves, and importantly their suspension systems, are designed to provide a comfortable ride for passengers and to protect freight from damage. The correct track gauge is important for effective functioning of these suspension systems. Deviation from the correct track gauge can lead to discomfort for passengers, excessive vibrations, and potential damage. There is also efficiency. As with any system, when it is operating as designed, it is at its most effective or efficient. At the correct gauge, the resistance to the movement of train wheels, known as rolling resistance, is lowest. This low level of friction reduces the energy required to move the train, thereby reducing the fuel or energy consumption of the train. In a similar vein, the track components will also be subject to less wear and tear, so less prone to failure or requiring less maintenance, which leads to reduced costs. Gauge faults may seem more minor compared to the other track faults, such as twist, but they do have a larger effect than most people appreciate. So what causes them? Gauge faults, or gauge variation as it's sometimes known, normally have a root cause in the failure of a component. Top of the list are fastenings, base plates or screws. The main function of these components is to maintain the gauge, so naturally, when they stop functioning correctly, the gauge deteriorates. The types of failure tend to be grouped depending on the sleeper type. On wooden sleepers, the screws securing the base plates to the sleeper are a particular weak point. The lateral forces of passing trains can cause these holes to elongate, allowing the base plate to move or shuffle. This can be visible on the sleeper, as the base plate movement wears on the wood. The screws can also shear, a more likely failure on concrete sleepers, given the tougher material doesn't allow the holes to deform. This can be a real issue because to the track patroller walking through, it might not be obvious that there is an issue. It would only be apparent when a train passes, when the track system is under load. This is known as a dynamic gauge fault, where the train's force spread the rails. A static fault can be seen and measured without the presence of a train. Sleepers that have failed or are rotten can also be the cause of the issue, as they are unable to restrain the base plate and thus the rail. Typically, a number of consecutive sleepers need to be affected to allow gauge variation to occur. Moving above the sleeper to the base plate, wear in this area can create what is known as chair gall. This is when the inside of the base plate surface next to the rail becomes worn, normally from movement. The additional space between the rail and the base plate allow the rail to move outward, increasing the gauge. Left unchecked, it can also lead to the housing being worn right through. Next, we get onto clips and insulators. Again, if these components become worn or are not in place, the rail can move outwards. This is most commonly found on tight radius curves where the lateral forces are high. Lastly, we get to the rail itself. We have said that gauge is measured from the running face of the rail. Well, if that is worn, naturally the gauge increases. Conversely, if lipping is present, it decreases the gauge. Wear on the rail face is a more common issue, known as side wear. This changes the profile of the rail and can only be removed by changing the rail. It is again most likely to occur on tight or incorrectly canted curves. We've spoken a lot about wide gauge, the more common gauge fault to find, but how can tight gauge be caused? Firstly, incorrect installation of base plates on timber track, simply putting them a few millimetres too close together. This could happen while re-drilling base plates in an effort to treat a wide gauge fault. Similarly, if a wide gauge fault has been corrected by moving the base plates, but side wear is present, if the rail is replaced later and the gauge isn't checked, a similar issue can occur. Another failure is sleepers out of square. If a sleeper is not at 90 degrees, as it should be, it naturally pulls the rails closer together. This can happen if the rails have different stresses, causing a different amount of thermal expansion in each rail. So what can be done about a gauge fault? As we have seen, most gauge faults are caused by failed components, so replacing these components will address the issue. But this might require a specific access to the track if a large amount of work is required, or materials to be ordered and delivered to site. So in the intervening time, if it's a wide gauge fault, tie bars can be fitted. This bar fits under the rail and holds the rails to the correct gauge, stopping further spreading. Given the forces involved, they require replacement at regular intervals, as they can stretch and deform under repeated loads. Thank you for watching this video. Please don't forget to give it a like, drop a question in the comments, and hit that subscribe button.